what happened in your life that you became so passionate for robotics?
When you see AI in the real world, you can touch it, you can interact with it, and that physical being, the physical thing is actually like intelligent. That's an amazing feeling.
Now I'll put the demo of the robot you've built. How did you build in 8 months? What skills were needed? How did it happen?
I think like it's a combination of different things because I think Microsoft में भी काफी help हुआ उस चीज में. When I went into Microsoft, what I learned is the aspect of collaboration.
What is the future then? Like how many days, weeks, years we can see it in hotels?
Our goal is कि 2025 के end तक we want to like have a product in the real world.
Why were you able to build the robot at MIT but not at IIIT?
I think it's the.
So hello everyone, today we are in the office of Founders Inc., which is a VC which gives you space to work out of as well. So now it starts with these cool cars. You can drive around this floor. Can you please give us a little bit tour of the floor?
For sure. So this is like, you just like sit here Japanese style, and then this is a huge TV presentation. These are like tiny booths for phone calls. So you just like, if you go in, there are like a lot of booths to take phone call. But then this is kind of like a full space. They'll give you the desk, they'll give you ergonomic chairs, they'll give you monitors. Usually they have like talks and all here, but now you can also do this.
Yeah, and they have a 2-week program as well. You apply and you can work here, right?
Oh yeah, you can do that too. They have like kitchen.
Oh, and they have free food all the time.
Oh yeah, they have free food. Amazing free food. I have to
Really?
say. So good. It's like if you want to become healthy, come here and eat. It's
Wow.
like so good.
This is the office space of Tangible. So can you walk us through what is here?
We are trying to build the first version of our robot. So we have already built a proof of concept. Bipasha built it at her MIT lab, and we want to build our own version, of a humanoid robot. And the first thing that we are trying to do is take this particular arm and actually fix it like a shoulder joint and try to do some dexterous tasks. So it will be mounted like a shoulder, like a humanoid arm, and we try to do a lot of different kinds of things like grabbing from the fridge, like objects from inside the fridge and things like that. So we are currently in the process of designing the mount for this arm.
Okay, so this is the arm, and these weights are just to balance it.
Oh yeah.
Okay, awesome. Amazing. So can you introduce yourselves?
I'm Shankara. I'm the Chief Research Officer of Tangible Robots, and I just finished my master's in robotics from Northeastern University, and joined on this journey with Bipasha to create the personal robots for households. Like that's the dream. That's the next.
So now meet the third co-founder, Benjamin. Can you please introduce yourself?
Oh yeah, sure. I'm Benjamin, CTO of Tangible Robots. I'm trying to bring robots into everybody's homes.
Oh wow. Can you walk us through the room? So what parts you're working on?
Yeah, so currently I'm making a mount for our robot. It's gonna be pretty simple because we're just trying to like iterate quickly, but we have this like big stand that's gonna sit on like a dolly-like system, and our goal right now is to just have the arm in an upright position. So earlier in the week, I was using the CNC to make the mount, and right now I'm just making like a wooden plate. I just wanted to like reduce vibrations and kind of have the wood will help with that. Basically.
Can you show as well, please?
Yeah. So I made this stencil. It's a little messy, but I basically all I care about is that the holes match up in proportion to each other. So I have this like 3D printed stencil hot glued to a piece of wood, and then I'm gonna go ahead and like drill all the holes in here.
Oh, very nice. Hello everyone, today we have Bipasha here. She's working on humanoid robots. She started her project at MIT. In 8 months, she had a prototype of working humanoid robot. Now she's in San Francisco at Founders Inc., where we are right now. And she's making the project ready to be used at hotels and soon by consumers at such a fast speed. So hi, Bipasha, can you please introduce yourself?
Yeah, so I am Bipasha, like Harnoor introduced me. I'm currently a founder of this company called as Tangible. Before Tangible, I was a PhD student doing robotics and AI at MIT. And like he said, I made my own humanoid, and at some point I felt like I wanted to make this a reality in the real world. And so when you get that conviction, there is no more waiting. So I was like, I don't want to wait for my PhD to get over. I just wanted to do it right now. So I just like decided to drop everything, move to San Francisco in December and started this. I also I worked in Microsoft before my PhD. I did my master's from IIIT. What else do you want to know?
So you're a machine learning engineer at Microsoft for 4 years.
Yeah.
Okay, so first of all, I want to start with your experience at IIIT Hyderabad. You did your master's there in machine learning, right?
Yeah.
Okay, so why were you able to build the robot at MIT, but not at IIIT?
Oh, I think it's a lot about the priorities. At that point, my priority was more to dig into the research around computer vision, AI, build a base. And obviously, MIT has so much more resources. I could build the robot because I had access to the right arms, which is the entire setup is $120,000.
Wow.
Yeah, so it's pretty expensive, but also the kind of people you have in MIT, the undergrads, the masters, they're so talented. So you can really get people together to build something like that. It's so much faster if you do it in a college like MIT.
So let's say that, currently NVIDIA CES, and even at NVIDIA GTC conference last year, they launched Omniverse. So you can see the prototype of robots. So let's say it was available at a cheaper cost. Would you have been able to build it anywhere, basically? I'm just trying to see how much MIT helps students build robots versus if you have a cheap resource like NVIDIA prototyping tools like Omniverse, and you can build anywhere.
I think for sure, you can build anywhere because I know personally a company called as Perceptine. When I was doing my master's in IIIT, I met them, and they were starting with something, and now they have a robot. I don't know if you know them, but they have their whole full robot functioning. So it's pretty cool. You can do it anywhere. I think there is resources, but what you get at a place like MIT is the speed. Because, you have everything readily available. You don't have to worry about, I need to raise money, I need to get this. If you wanted to get something very expensive, you don't have to think about, oh, it's too expensive, I can't get it. I need to find another way to do it. But you can always do so if you need to. So that's why.
Okay, so quickly, 2 important messages for all students. If you have taken loan to come to the US, if it is in US dollars, it's worth it. Even if you are an F1 visa, H1B visa, to refinance it, because many students on Reddit reported, on X reported that their interest rate dropped to less than half, less than 7%. Some people have interest rate more than 10%. They take through Prodigy Finance or other places. You can reduce it to 5 to 7% with SoFi, because with SoFi, irrespective of your visa, you can refinance immediately in just one step with the link in description below. And even if you want to open the bank account, that's completely optional. You can check out the link as well. Number 2 is, if you are coming to the US, if you haven't tried Mint Mobile, you have to try right now, because starting at just $15 per month, you get unlimited 5G, unlimited calling, unlimited text messages, and roaming in US, Canada as well. So what are you waiting for?
Enticing, right?
Whenever I go to India, I just add additional roaming, and it's almost my 5th year starting with Mint Mobile, and it's my favorite career provider in the US. Go check out both in the description below. Can you share what happened in your life that you became so passionate for robotics, from machine learning, or even passionate for machine learning, and how we got here?
Well, I think since my undergrad, I was so passionate about AI just because it's a cool topic, artificial intelligence. You want to see computers sort of think for themselves. But the reason I got into robotics was because I did AI for 5 years in Microsoft in my undergrad. Everything complete, everything end to end. I was doing AI, and then there was a lab in IIIT called RRC, Robotics Research Center. They work in robotics, and then I can say in Hindi, but the feeling of when you see AI in the real world, you can touch it, you can interact with it, and that physical being, the physical thing is actually intelligent. That's an amazing feeling. So ever since I had this feeling, I was no way, this is so cool. I want to get this feeling to everybody's hand. And so that's how I kind of came into MIT with the goal that I wanted to make robots a commonplace. And it was just more of a question of how do I want to do it, more than if I wanted to do something like this.
Interesting. So can you share what were your topics that you were exposed to at the time, which led you to robotics? So I want to talk about the evolution of machine learning topics that you were exposed to that inclined toward robotics, because it was not a straight line curve, right? Because tab hum baat karte the CNN, it started with AlexNet, which was a research paper by Ilya Sutskever, which was one of the revolutionary one, and I don't remember the later papers, but yeah. So from there, it was in 2017. And we reached here. So, and especially in robotics, even at CES this year, Jensen Huang shared the trajectory of fully autonomous robots. So now we are with LLMs, generative AI, then next is agents, then robotics, and fully autonomous robots. So that's the 5-year trajectory.
Yeah.
So how did we reach here?
Well, a huge shift came because of LLMs. And I think what I believe in the most, I always did, is the fact of like data. Like the way ML works is if you have the right data in the right amount and you just feed the neural networks with it, it'll just learn things. So I think 2 things. One is the architectural innovation and one is the data set innovation. So architectural innovation may transformers aa gaye. And then you have things like diffusion policy, which is why we have image generation, video generation models today. So once that happened, it was all about getting the right data that can feed into these architectures and make something out of it. So LLMs basically, OpenAI collected this huge database called Common Crawl, and they fed it into transformers. LLMs aa gaye. And once you see LLMs, once you see that kind of AI, which is like more intelligent than humans, people just start believing that anything's possible. And robotics, I think, I think when I was in IIIT, the kind of problems that we were solving with robotics is so different from the kind of problems today. Because we had just like one arm, which is trying to do like a rearrangement on table, and the robots were like so dumb. I used to think like, ye kya state hai robotics? But today, like you have like robots doing so much. So there's a huge shift fundamentally because of LLMs, because of image generation. लोगों को realize हो गया है कि you can actually do all of these like very, very intelligent things with non-humans. And that's where the shift came, and like people are moving into this.
Okay, so you were already following all the topics during your undergrad transformer. So you were always up to date, or suddenly it happened, you got into space?
No, I think I was always, at least at that time, jo current tha, wo to I was always up to date. I think I started doing CNNs, RNNs in my undergrad. And then as the techniques involved, I was always in touch with them. Ekdam starting mein, I was actually like more interested in speech. The reason is I'm like a musician.
Oh, wow.
Yeah, so music and speech are related hai. But then I was like, bahut hi jaldi I realized that, computer vision is much more interesting because you can like do so much with it. And the story is basically, I was in this lab called as CVIT. So this is one of the best lab in India. So if you have to go for research anywhere, go to CVIT with Jawahar sir.
In IIT Hyderabad?
In IIIT Hyderabad.
IIIT Hyderabad.
Yeah. So, and then I was just in that lab, and then I heard about like somebody just like brought up this point that, oh, there is this guy called as Madhav sir, and he's like, Madhav Krishna, and he's working with robots. And I was like, robots, that's so cool. So then I became like a student in his course. So he's taking a course called as mobile manipulation. And I became like, I would answer all of his questions. I would let sir doubt. And I became like this very known person in the class. And then he knew me. And then I was like, can I please do a research with you? And he's like, fine, just come. He didn't expect much. But then I performed so well. He's like, yeah, please continue the collaboration. And wahan se I became so involved in like robotics that I actually like did not do computer vision much. I did robotics more. And Madhav sir was like so confused. He's like, oh wait, I thought you wanted to do a PhD in computer vision. I'm like, no, I want to do it in robotics.
Wow. So because like India is ranking really fast in top 100 universities as well. Did you see that ISC Bangalore is in top 100 in the world because of research ranking going up? And I think IIIT Hyderabad is also in top 200, 250.
Yeah.
So India is accelerating in
yeah.
education at a really fast pace. So my question now here is, I'll come back to how to get started with robots and robotics, especially later. So can you share why did you leave MIT? You dropped out of MIT officially.
Yeah.
So you built a robot in 8 months at MIT with your team. Now you could have finished the project and maybe launched it there as well, or you had to come to San Francisco to drop out after dropping out.
Well, I think one thing I really believe in life as a concept is speed. So whatever like you have to do it super fast, and you don't have to like think about ye option, wo option. Like when you go into something, just go fully in it. Like there is no secondary ki PhD bhi chal raha hai, ye company bhi chal raha hai. Like full on. If you have to do something, do that one thing. The same in masters. Like one of the reasons I did my masters was because I wanted to get a PhD, and getting into a PhD in like AI is not a joke. Like you have to like. It's crazy hard. So,
especially at MIT, you know, it's really, really hard.
Yeah, so like the same happened. Like I was at Microsoft. I could have just like been in Microsoft, side my research I could have done. But at a point I realized, nahin, wo nahi hoga. I want to do a PhD. I have to like quit Microsoft. And so I like became a researcher in MIT, in IIIT. And the same realization here is like, this is what I want to do. This is what I want to make happen. And so there was like, no fallback of nahi ye bhi karti wo bhi karti. No, this is it.
So you wanted to go all in.
Yeah.
So for viewers watching, I want to give more data of what she's saying. So I saw the data that students who get into top US universities for PhD, especially Indians, 90% of them, especially at MIT, are from IITs. 90% plus when I visited. And most importantly, jo IITs se nahi bhi hote, they have, non-IITs have, like non-IITians have papers which are at least 2x stronger than from IITians point of view, because universities mein jo professors hote hain, like professors at universities, they just don't know other universities than IIT as much as IITs. So unke liye reputation is either IIT or good reputed papers that you have written. So since you were not from IIT, you went to IIIT, what level of papers you wrote?
Well, just like top conferences, NeurIPS.
Wait, I figured it out. Like,
NeurIPS, KMLR, Kepra.
I knew it, that it has to be that extraordinary. So can you share the hard work behind getting into MIT? So how many papers, what level of publications? NeurIPS, it tells you, 60,000, I think thousands of researchers go there. Elliot Sutskever last presented in NeurIPS Vancouver. It's a big conference for researchers.
Oh, yeah. It's like, NeurIPS is like A-star. It's like the best conference of any ML. Like ICML, NeurIPS is like one of them. Well, I would say though, that IIIT is, I think, very, when it comes as just a concept, IIIT, it's very underrated in India. But in the US, IIIT is actually pretty well known, because बहुत अच्छे researchers IIIT से आए हैं. So I would say, like, if you're thinking seriously about research, there's only like 3 colleges that are worth it: IIIT, Hyderabad, IIT Kanpur, or IISc.
Bangalore, of course.
Yeah, but उसमें भी I think IIIT का unique edge इसमें आता है कि there is so much of diversity. Like IIIT is good in computer vision, speech recognition, earthquake. But I don't know what they do, but they do something. Quantum. I know somebody who like published papers in quantum. He was like so intelligent, so smart. He went to like Amsterdam to do some quant, whatever. But like then robotics. So the diversity that you get into IIIT in terms of research is like amazing. So if you're serious about research, actually, like I've seen people coming from IITs to IIIT to do research. It's that good. So I think more people need to know this. It's like a hidden gem of India at this point.
Mind-blowing. So what it takes to write papers that reach NeurIPS? ऐसे मजाक नहीं है कोई भी MIT पहुंच जाए.
Well, actually, like it takes the right mentorship. Like I think mentorship is extremely important. Without Jawahar sir is like he's actually like one of the best known researchers in India. So everybody knows Jawahar sir, and he is the one who got me into this very right track. And unke jo unke lab mein there was a group called as just like I don't remember the name of the group, audiovisual lab basically, and they had a few students. And oh my God, like those students were like, they're publishing paper every 2 months. and like good papers, all A-star papers. So once you get into that environment, you know, ki, oh my, I have to outcompete these people because you're competitive in nature. So you just like see somebody performing well, you're like, I have to now do 10x better than this. So that's how like with the right mentorship, the right environment, publishing research paper is not that intuitive, like because you need a lot of background, you need to know how to present something in the right way, you need to do the right thing. They won't just accept anything. Before I came to IIIT, I actually tried publishing in Microsoft. It got rejected, obviously. When I came to IIIT, like the entire game, I understood what it takes. It takes basically a lot of depth. So you need to have a very, very good understanding of the topic. You need to know where is the area where you can actually like change something. And then you need to do the right kind of experiments to prove that whatever you've designed, whatever you've built is actually like the efficacy is good. And then you need to design like a paper that can present all of these results in the right way. Then you need to do rebuttal. Like when you submit the papers, the reviewers will come back with extra questions and they're like, no, this is not good, this is not good. So you need to understand how to rebut the right way. So a combination of all of these leads to the right paper.
If you have to break down the depth part in steps, ki pehle ye karo, like step by step, like how do you depth? So like you test the product, reach out to the experts, like break down the depth part in research.
I think a lot of just like studying, just like when you're doing research, you have to read like 100 more research papers basically. And you need to be in a state, or you need to be in a, you need to have that kind of hold on the topic. When you're reading these 100 research papers, you actually understand them. Because I know कि I tried doing research thoda pehle Microsoft maybe, but the experience was like of half of the things I couldn't even like get what it meant. But with the right kind of like practice, just like honestly, like when I started like my ML journey, I started with the Andrew NG, like Andrew Nig videos. So it's the same story. It's just like you have to like keep at it. You need to get deeper, read actual research papers, talk to the right people, and at some point implement, code it, implement it, get the results, and at some point you just like get a hang of it.
And now I'll put the demo of the robot you've built. How did you build in 8 months? What skills were needed? How did it happen?
But I think like it's a combination of different things, because I think Microsoft maybe काफी help हुआ उस चीज में. When I went into Microsoft, what I learned is the aspect of collaboration. Like in Microsoft, I was leading my own team, and we were shipping to like 100 million users globally. Usme, I had to like talk to people across different continents, like Europe, US, India, and get us unblocked. Because, you know, like when we as a team, we're like blocked on 2 different teams, and you need to like get them to do something that you need to get yourselves unblocked, but unke liye it's not a priority. Right, so like you have to get on a call, you be like, "What the fuck?" Like, do it, and then so that skill of like managing people, just like getting people together to work on something, I think that came in really handy in MIT, because unlike a lot of people, the first semester I had my own undergrad researchers. So usually like you do like you publish your own papers and then you get people to like work with you. But the first month, my advisor is amazing. So kudos to him, obviously, Pulkit. He's the professor at MIT. So he's like so open-minded, so ambitious himself. So yeah, wahan pe hi I started like getting my own undergrads. I knew I wanted to build a robot. I had no hardware experience, honestly. So this is the first time I did hardware. So I just like needed to find the right people who can like do stuff for me and like help me out and like teach me things. So it's just like a lot of like jugaad. Honestly, this is just like a lot of jugaad.
So how much skills you learned on your own, and how many skills you just like leveraged to others?
I think my main skill is AI. Like I think even for robotics, I know what it takes to like build an algorithm just jo use karke you can make autonomy for robotics. But hardware, maybe I've started to understand like kya chahiye hota hai, where is the missing piece and so on. But when I came in, there are like still so many things I don't understand. But I get the design aspect, like I get the mechanism aspect. I knew, so basically it's like you want to build something, but you know intuitively what it has to be like, you know where it needs to end up. So you just like need to find people who can execute, who can like, maybe I want a particular design. So I had to like learn CADing, but you can also like get people to do that part for you. So I think what I'm good at is AI, and also like designing mechanism, understanding the mechanism, intuitiveness of where the product needs to be, and then like find people. If I don't have the right skill to do it, just like find the right people to do it.
So can you break down the process? So the robots in the demo is like, it is ironing the sheet, right? That's the basically demo.
Yeah.
So how did you design the algorithm? What it took? So breaking that down further.
Yeah. So I think like when I first started, I can tell you my MIT journey basically. When I first started my PhD, my goal was to like, how can we accelerate? Like what I fundamentally believe that to accelerate anything, you need the right data. And the question I wanted to address is like, what is the right process for getting the right data for robotics? And wahan pe, when I first started, there are like so many different conversations, People are like, why do you want to fix this? Abhi tak to robot hardware bhi sahi nahi hai. And I'm like, I had like my one robot. I can share the videos with you. But there's like one robot in a weird like configuration. I love that robot. That's what I used in the end. But people are like, ye to ye nahi kar sakta, wo to ye nahi kar sakta. It can't go into homes. So I was like, chuck it. I took it to an Airbnb, and I was like, I tried doing stuff with it. So that was the first level of validation. People can have like 10 different opinions, but you need to validate like, what they're saying. They're all biases, sets of biases. So you need to validate for yourself. And then I realized hardware is actually pretty good. Like it's pretty solid. What you need right now is the right software. And then there is something called as teleoperation. So teleoperation is the way you operate the robot to do a particular thing. And just like collect enough demonstration, then you use something called as imitation learning. And imitation learning is karke you can just automate whatever demonstration you showed the robot. So Pulkit, just like based on the ideas that I was having, Pulkit introduced me to this guy, Brandon. He had his own teleoperation rig like set up, and I really liked it. So I just like incorporated it to my thing. So his teleoperation was for just like one arm. So I built my own like bi-manual teleoperation rig. I designed my own system. I knew how it should look. Then we tried getting in touch with like design partners in the US. They're like overcomplicating everything. So I was like, chuck it, like we'll design our own thing. So we just like ordered parts. Brandon helped me with this, and ordered parts, made the robot. I wrote the entire code for the bimanual teleoperations. Then it was also mobile, so it could like go around. So the entire code base for teleoperation. And then once that part was done, I wanted to validate, would imitation learning actually work for like an embodiment like this? So the first step of validation was like collecting demonstrations and just like using the same algorithms here. And then the work I did at MIT was just realizing the camera angles. Basically, when you're teleoperating, you're at a distance and the robot is there. So you have to like teleoperate, and you have to like imagine ki robot kya dekh raha hai. And robots में cameras होते हैं to capture the data, like the environment. And उसके हिसाब से like those are the observations, and we try to like train algorithms based on those observations. So cameras are fixed, and humans don't operate like that, right? Our neck are like moving, so cameras are actually moving. And so I was like, this is what it needs to do. The robot needs to have a head that can move with me. So we designed the system where we actually put an arm that became the neck, and with the VR, I could also move the neck, and then I applied the imitation learning algorithms, and it could actually like look around and then figure out its own right point of view to do a task, which improved the generalization quite a lot. So this is how you figure out, like you do stuff and you see like, oh, this is missing. So you try to fix it, and then something comes out of it.
Yeah, at CES also I saw a lot of robots. जो VR headset से person wears the VR and then controls the robot to train it, and उसके बाद you can deploy it to multiple places. So that's the demos I saw. So tell me why your robot is better than the competition, and what does exist in the competition right now? Because you getting into Founders Inc. is not a joke, right? So there's something better, and it is of course better. It's such a cool demo.
Yeah, so I think there is a huge difference between when you see something work in demo in a research lab versus when it actually works as a product. in the real world, right? तो बहुत सारे differences होते हैं. तो मेरे with my prototype, what I did was I wanted to use as many real objects as possible and diversity. So if you think about one, usually what happens is you collect the demo for one task and you automate that task. But मेरे case में I wanted to like automate multiple different tasks and have the robots do multiple different things. So what I really wanted to fix is this gap. Key research environment may you have the robot that works because the environment is set up in a way that can showcase the novelty of your algorithm, but that doesn't mean it will actually work in the real world. And so that's what I wanted to fix. I actually wanted to put robots to use in the real world. Like how many times, like how long will we see robots in a lab setting doing something for us? So then that challenge is like completely different because you actually need the robot to not break. Like actually like you want the interface between the human and the robot to be good enough so that you can operate the robot for like 8 hours, 9 hours, 10 hours a day. And the human operator should feel like, oh, I can do this because the interface is like so good. So I'm talking about teleoperation.
Yeah. So let's figure out the steps, right? So no, let's talk about all the points which are better than the competition. Number one, your robot can do multiple things at once. It can have multiple hands. It can iron as well, and let's say it can like put dishes in the dishwasher as well. That's what you're saying.
So no, that's not what I'm saying. So when you think about an ML algorithm, basically, the ML algorithm there is something called as task-by-task learning, which means कि suppose iron करना है. So you collected 50 demonstrations for ironing, and the robot can do ironing. That's it, and the robot can only do ironing on this table. Now, if you want the robot to do ironing in your house, it wouldn't because उसने कभी वैसा data ही नहीं देखा है. And if you want the robot to fetch this bottle for you, the robot wouldn't be able to because उसने कभी ऐसी चीज़ की ही नहीं है. So what I am focusing on is like how to generalize. Like how do you like go beyond just ironing? How do you do multiple sorts of things? And my thesis is basically कि when you want to build this kind of like a algorithm that can do all of these multiple things in multiple environments, you just need the right data initially for it. So I want to use teleoperation and I want to deploy the robots in the real world so it can collect these kind of diverse data through teleoperation and then build an algorithm that can merge all of this data and train on it. So my play is data game, I would say. Like I'm trying to build the right database for robotics.
So that's the moat you have because you have more data.
Yeah.
And you have trained it with your own like data centers.
Yeah.
So how do you train those? What's the process like?
No, it's not trained yet. So it will be trained because like I said, like robots are just not there in the real world. Abhi hai hi nahi robots. So and that's the reason that's one of the reason I dropped out because you can't do this in a lab. You can't put hundreds of robots in the real world from a lab. You'll be like limited to one environment, one robot. You do your research, you figure out what's missing, and you like build algorithms, which is good. But what I want to do is like I want to solve this fundamental question of how can we make it a reality? How can we get it in front of people? How can we make it like just like हमारे बाजू में ही चल रहा है? So yeah.
So are you the only one which is working on this?
No, of course not. Like robotics is like such a emerging field now. There are like I can name like 10 companies right now working on this, but I think for everyone there is like a bit of niche. So I can name some companies like Physical Intelligence, Skilled, all of these companies, they are trying to build foundation models.
You can name some like Physical Intelligence?
Physical Intelligence, Skilled AI, and their goal is to build the best research algorithms. So like how I was mentioning ki transformers hota hai for language or speech, and then you have diffusion policies for images. We as a field, robotics as a field, we are trying to find out what is the right architecture for robotics type data. And that is the goal that these people have. A lot of people also have the simulation goal. Simulation you can have a lot of data. So how can you leverage it to like improve your algorithm? So that's where skilled physical intelligence comes in. NVIDIA is in that category.
Yeah, they have all the tools.
Yeah.
Okay, so there are different areas. So since there are so many competitors, the biggest moat you can have is speed and making it multi-purpose, which you're doing it.
Yeah.
Awesome.
Yeah.
And what is the future then? Like how many days, weeks, years, we can see it in hotels and then consumers?
Our plan is, our goal is कि 2025 के end तक we want to like have a product in the real world.
Wow.
Yeah, and then 2026 is when we will like properly pilot in like selected hotels. So like limited number of robots, so we can like figure out everything. But 2027 is basically when we like scale. So that's the plan.
So what's the biggest skill you think you've used to reach here?
Biggest skill, I think I've heard this from a lot of other people. Like I'm just like a go-getter. So if I want something, I'll just like go and get it. So I think I don't know if that's a skill, but that's a personality that I have. Skill, obviously, like technical, it's such a deeply technical topic. Like I don't think all of my background has been in the past 3 years around robotic manipulation. And robotic manipulation is like different from just robotics, because when you think about robots, you can think about things like robots in the airport or robots in the grocery stores that's doing floor cleaning, different inventory management. But robotic manipulation is when the robot is actually like interacting with the world, like picking, placing, opening. So this is the hardest, I would say, part of robotics. And so I've built in the past, all of my papers, they've been like around robotics manipulation. So this is what like gives me the confidence, and I think a sort of like an edge over maybe other companies that are trying to do the same thing, because I have like the experience.
Yeah, because most founders also say, like, I was reading a book in my story likhi thi of Virgin Atlantic Group. The CEO at one point had autism. He couldn't figure out ki net or gross revenue mein difference kya hota hai. And he always said that the right question is not how, it is who. So he's just like, I have hired good people who will tell me what's gross and net revenue, they can tell me. So the biggest thing is you hire the right people, even if you don't know. And you had so much knowledge that both combined became, the big thing. So one last question I would have is, from visa point of view, dropping out is not easy. So how does that work?
Well, this is like I came on an F1 specifically because that gave me the time. But you need to get an O1. And with all of my profile, I just put in the extraordinary category. I have like a bunch of research papers, judging and everything. So O1 is just like the EB, green card, but it's just not a green card. You'll have to keep renewing it. But you can get it anytime, as long as you qualify for it.
So you can go get O1 in like within 15, 20 days, right?
No, you can get an O1. I think it would take about like 1.5 months, realistically, if you have the best lawyer.
So you got in 1.5 months, and the moment you got it, then you dropped out officially.
Yeah.
Wow. Okay. Yeah. Awesome. Thank you so much, Bipasha. It was wonderful talking to you. Incredible insights. I hope this video helps and inspires other people.
I hope something I said helped others too.
Absolutely. Thank you.
Thank you.